Good afternoon, everyone. Hope I am audible. Okay. So today our focus is on the array parameters, memories, and string. Okay. So this is what our primary focus for the today's session. Let me wait for 2 minutes so others can join. I see there is only 5 people are joined. I don't know. Might be the link as okay. That's not a problem. Open the practicals. Data, primary array memory and these things. Okay, anyway, those who are they will be recording sessions where they can go look into it. So Verilog provides construct to improve modularity, configurability, and data storage. So these includes to improve modularity, configurability, and data storage. There is an something called arrays and called parameters, memories, and strings. So these are the things, and these are very useful in reusable register transfer logic modules, and then configurable hardware design, test bench development, memory modeling, protocol message handling in simulations. So these all are very much useful in these stuffs. Okay. So now, what is the arrays in Verilog? Okay, what you think that arrays in Verilog? An array is collection of multiple elements of same data type. This is very much important. Okay, so this is of having the same data type. It is used to store groups of registers, lookup tables, memory blocks, repetitive structured data. So these are the things, and two common concepts: vector, packed bits, arrays, multiple elements. So what is the difference between the vector and the array? Okay, so vector is multiple bits at one signal. You see that, okay, this is data is one signal. This signal has multiple bits, that is 8-bit. Okay, one 8-bit signal. Array is a separate element. You have 8 signals. That is what. Okay, so here the meaning is, okay, so 8 separate 1-bit storage. It is nothing but 8 separate 1-bit storage. This is the thing. Okay, so this is the difference. This is array. Okay, but this is a signal having 8-bit. Okay, you have to think this one signal, it is having an 8-bit. Such a kind of things you have to look into it. Okay, so now you uh, what I will tell now, here the data of 0 is one signal. It can carry, it will have only 1 bit, but here, okay, it is something, the multiple bits of signal, something like what you call, this is a one signal having multiple bits, but here it is separate. Data of 0 is a separate uh, thing, and data of 1 is a separate signal. So these are the separate signals. Okay, when we try to combine it, you can have a memory. Okay, so this mem of 0, in that mem of 0 you have 8-bit, and mem of 1 you have 8 bits. So each is having 8 bits. So that is what this tells. Okay, so when you try to use a syntax something like this, okay, so you will get the things like this. Okay, now in the array declaration, how are we going to do? Okay, so the data type, whether range, wire, such kind of things, we will go and use it. And the vector range we are trying to give, and the array name, and then array range. So it is of having 32 buffer, of each buffer is of having 8 bit. Okay, so the b of 0 is having 8 bit, b of 1 is having 8 bit, b of 2 is having 8 bit. Okay, so this is the idea, the difference between the vector and the array. How do we access the array? Okay, so it starts from 0 to the maximum thing. Okay, so with these indices where you can go and access it. Okay, suppose if it is a two-dimensional array, you can use by this. Okay, so it is, the meaning is bit 3 of element 5. Bit 3 of element 5 is something like 5 3. So now in the assignment, buffer 2 is equal to, the size is 8, and the value we are putting in an hexadecimal is a of 5. Okay, so these are some examples which is related to the array. So where we can go and use this array in our applications. Okay, suppose if our hardware, if we want to go and use it for RAM modeling, ROM modeling, I mean ROM tables, register banks, FIFOs, lookup tables, packet buffers. In all these things, we can go and use this, uh, what we call it as this array stuff, where we can go and use it. Okay. Now the parameter. Okay, so you can have a module. You see, we have seen a module, and we have created the name for the module, and we went and used the input and output for that module. This parameter which will allow us to configure the module design. Okay, think like a compile time constant. So it will use to avoid hard coded values, and then it will make the modules reusable, create scalable designs, parameter name is equal to value. We can use name and the value. When it comes to the example, you will able to see it. Okay. Okay, many are sending that. I hope, is the screen visible? I don't know, some problem in the stuffs. Let me stop share it, and then let me again share it. Okay, let me again share the screen. Okay, hope the screen are visible, and I think many are not able to join. I don't know what is happening in the, many are having the same problem, but I don't know why many are facing these issues. Someone confirm me, is the screen visible? Okay, yes, many are telling yes sir. I don't know. Okay, let me again, okay, escape it. Okay, and there might be some issue with these things. For others, they are able to get the things. One second, give me a time, guys. Many are. One second, give me a time. Whatever the thing, let me start the class. There might be some technical glitches. Okay, so no worries. Anyhow, we will be having an the thing. Okay, so for example, this is the module. The module name is counter. Okay, the module name is counter, and we have a input and the output ports. All the things are there. Okay, all the things are there. Okay, input ports and output ports. Okay, and you see that there we went and introduced one parameter. This is the syntax as symbol, and you have to open and close with parameter, and you have to write a parameter, and you can make the width, okay, something as 8. How means, instead of here writing a hard coded of 7, you can write 8, so this will be consider it over here. Okay, and we can override this, the width, when we try to instantiate this hardware. We can go and what we'll tell, we can go and change to 16. So you have a flexibility. Okay, that is what. So now it becomes a 8-bit counter. When we go on, while instantiating, when we try to pass the parameter as 16, it will go and change it for the 16-bit counter. So this is one good usage with the parameter. Okay, so the benefits of parameters is the reusable modules, scalable RTL, cleaner code, easier maintenance, avoid magic numbers. So we have a bus width, memory depth, timeout values, and FSM constants. So for these things, we can go and use this stuffs. Okay, then there is a concept called local parameters. There is a concept called local parameter. So it is something called an internal parameter. Okay, it is something called internal parameters. So local param, idle. Okay, I think many are sending the things in the group. Let me finish that and I will. Okay, okay, so for a time being, 1 second, let me check it again. Okay, let me share it from the current slide. Okay. Okay, so the local parameter, if you define a local parameter, we cannot go and override it. Okay, so it is used for FM state encoding and fixed constants. In the all these things, you can go and use it. Okay, so local param, how we can do is local param idle, local param run, and you can go and create it. Okay, and then if we give the state is something like this. Okay, and if you tell this is something like a done state, you can create a local parameter something like a done. Okay, and you can go and introduce this done and assign it to the state. It will be so readable compared to the binary stuffs. So these are some usage related to the things, the stuff. Okay, parameters. Oh, memories. Okay, memories. Okay, there is a spelling mistake. No worries. Memory in Verilog is modeled using array of registers. As I mentioned in the earlier, memory, and this is an array, and what is the width you want to go and use it. Okay, so as I mentioned here, we have a 256 memory location and each is having 8 bits. So totally 2048 bits you can go and use it. Okay, so that is the idea. And suppose there is a memory read, memory write, such kind of things. Okay, so where if you want to write something in the memory, you can write the data like an 8-bit data or such kind of things, and you have to give the memory address. Then something you have to put it in the memory address, you have to write what is the data, you can go and write it. Okay, so since we are using the reg always, and since it's a sequential, we are using post edge clock and begin and end. Okay, so if something, if we or something, if it is there to enable, if the wire is enabled memory address, and then we are using, since it is something we are to using an non-blocking assignment. Okay, so these are some examples to the memory. When it comes to the synchronous memory, read write tied to the clock. Read write is tied to the clock. That is what we were telling. Okay, so if it is enabled, it will go on right into the things, and then the uh, something from the memory, if you want to put, you can go and use this. So synchronous means something, it is connected with the clock. Okay, so for FPGA program, and then the uh, uh, realistic hardware styles, in these things we can go and look into it. Okay, one second. Okay, so many are facing technical glitches. Many are not able to see the things. I don't know what is the stuff. Okay, so after the class, I will intimate to them. For a time being, I cannot go and create a new link and go and do the things. That is not possible. Okay, so FPGA block. So now we will try to look it once. Okay, already 20 minutes has gone. So we will try to look these things. Let them see the recorded session. Okay, I don't know, some technical glitches was happening. Asynchronous read memory, immediate read response, assign d out memory address. So something like asynchronous. Okay, so immediate read response. Okay, here you will get there when we use the sequential, something like that. Okay, so there only through the clock where that sequential is getting stuff. Here asynchronous read memory, immediate read response, you will be able to get it. Okay, that is the idea of this. And we can go for a rom modeling, read only memory, fixed lookup storage, something like that. Okay, so we can go and assign 16 addresses, and each is having an 8-bit, and we can go and give an hard value to that. Okay, so something, it looks like a lookup tables and microcode sign tables and constants. We can go and use this rom kind of things. Okay, now from an external file, you can put it in the memory. So read mem binary, read mem x. Okay, so these are the things where you can use uh, uh, these are the commands where you can go and use maybe a function. You can go and read the data and put it inside the memory from the binary files, and from the exa files you can go and put it in the memory. Okay, so it is firmware preload, rom initialization, and text vectors. So these are something which you can go and look into. Now the strings in Verilog. Classical Verilog has limited string support. So strings stored as packed ASCII values. Example, something like that, reg, and I am using it from 8 5s of 40 is to 1. That means nearly 40 bits the message. Okay, so now I can go and assign a string hello into it. Okay, so it is an 8-bit, 1 2 3 4 5 6. Okay, it's an 8-bit of ASCII. What I am trying to tell is, okay, um, uh, sorry, actually it is okay, this is some typo error. It is a typo error. Okay, each message is of 8-bit, each character is of 8-bit, 1 2 3 4 and 5. Yes, it is correct, 40 Okay, so we are giving a 40 bit, and H, it will take 8 bits, and E, it is taking 8 bits. That is what it is, 8 bits of ASCII. But ASCII you can represent to 7. I don't know why they were using this, maybe because of the signed, some unsigned. Okay, and then the string examples, ASCII mapping. H, if you see the ASCII maple table, ASCII map table, you can see that H is something 48, E is represented by 45 in hexa. These are the things you can go on look at. This is an 8 bit, 8 bit, 8 bit, 8 bit, 8 bit. So it is stored in a packed vector. So mostly for simulation use, we will go and use such kind of things. Okay. So for debug the message, test bench label, simulation report, file handling, we will use it. You can use display, and then you can use monitor, strobe, such kind of things. Okay, so parameterized FIFO memory for an example. Okay, width is 8, depth is 16. So the D in is having a vector of 8 bit 0 to 7. This will be able to do it. Okay, and when we try to instantiate the memory, okay, you can write mem, okay, 0 to depth minus 1, so 16 bit. So this is some on example where we can go and use our parameters for our thing, and we can go and write into it. Okay. Okay, so the common mistakes is we will try to confuse it with vector and arrays, wrong understanding, and this is not 8-bit bus hard coded numbers. Okay, so something like that. And the better is you try to use parameter, because it is something like a hard coded number. If you use width minus 1 and something like that, it will be a good. Okay, so using initial for synthesizable ASIC RAM may not synthesize as intended, out of range induction. Bad. MEM 300. It is something like a bad they were trying to tell. Okay. So when only 256 entry exists. So expecting rich string support, classical Verilog string handling is limited. Okay. So in the RTL, you can go for parameter, local parameter, memory arrays, and scalable modules. And for test bench, this you can go and use strings, file memory, preload, debug messages. For the test bench, you can go and use these things. So it is preferred for synchronous memory and symbolic constants, and avoid try to give some hard-coded numbers, unsafe indexing, and simulation only construction synth RTL. Okay, so the modern STM, I mean system Verilog, the thing is no, the system Verilog. Right now we are not looking into system Verilog, but I am trying to give you notes on the system Verilog. It improves the multi-dimensional arrays, string data types, and then parameter typing, associative array, and dynamic arrays queues. But classical Verilog concept remain foundational. Okay, this classical thing is going to be the foundational. So vector, array, parameter, local parameter, memory, and string. What is its purpose? It is for multi-bit signal. It is for multiple elements that you have to try to understand. Configurable constant. You can constant the things, and fixed internal constant, and it's used for RAM, ROM, and modeling. And except the string, you can synthesize for the all other things. For string, it is only for a limited thing where you can go and use for the synthesis purpose. Okay, so in summary, where we can go and look into it. Okay, stored group element, parameters, memories, strings, mainly simulation, debug support, essential for scalable Verilog RTL design. So these are the things we went and looked for the theory sessions. Okay, so now whatever the thing we learned, we try to put it in an code, and we will try to look what how it looks. Okay, that is what our next idea. Okay, so in an array, I have some. Okay, let me open the terminal, and then let me open that also. Okay, so this I am using it. Next, this I am using it in this way. Okay, so somehow I am able to, and let me, okay, so this is what, okay, now for the explanation of an 1D array, I create a dummy module where there is no where there is no an input or output port I am trying to give. Okay, just I want to display how these arrays they are able to get. Okay, for d of 0, what is its value? These things. Okay, it is similar to that. Okay, I Verilog, and then the thing is 1. Okay, and then VPP a dot out. I am able to access the each and every content by using the index element. Okay, by using the index element. Now in the array 2, okay, in the array 2, how are we going to initialize the array? It is something like a hard-coded initialization. By using the loop, you can go on initialize this array. Okay, so I know the array is of 8 element, so we'll go and use it. And how to display it, you can display by using such kind of things also. Okay, so let me go and the same thing, I Verilog. Okay, in that we are able to get it. Okay, I Verilog to array, we are able to get the things, and then VVP and then a dot out, I am able to print. I'm able to actually, this has been get stored, and then by the use of display thing, I'm able to print the things. Okay, so this is one. Okay, next, accessing the array. Okay, uh, any particular element, you can go and use this. Okay, so these all are the same stuff. There is no much of the things. Then the same thing I am trying to access by the array through the loop. Okay, that also we went and looked into it. Okay, now the array of vectors, this something we have to understand. Okay, we are creating a 4 element, and in the each element we are trying to store 8 bit of data, 8 bit of data, and how we are going to access. Okay, so easily, okay, it is like we want to go and change this location 0 1 2 3, and then automatically, because it is signal, each is having a signal, so with this one we will be able to do that. So when I try to compile it, I Verilog. Okay, when I try to compile the I Verilog, and then what is its name 5. Okay, and then VVP a dot out. Okay, so we can see that in the each we have a 4 element, and each is having a 8-bit data. We are able to store it. It is something for the memory. You can go and use such kind of concepts and do it. So now comes the 2D array. Okay, 2D array, what I'm trying to do is, so you think of the row and the column, such kind of things. Okay, so each thing is having an, you can tell 8-bit. Each thing is having 8-bit. So I have 4 locations, 2 dimensionals of 4 locations. Okay, so to access the by moving inside the one of the column, and then there I will go and run the moving into one of the row and moving into the 2 columns. Okay, so here it is similar like that. Okay, it will hard to think and imagine for simulation, but once you guys used to it, it will be of good. Okay, the same thing, but we are trying to use a 2-dimensional stuffs. Okay, we are trying to use a 2-dimensional the thing. Okay, so that is the thing. So the array is of it is of not what I will tell, it is not that much complicated. Okay, let us try to concentrate something towards this parameters. Okay, so for that I want to move inside the parameter itself. Okay, so as I mentioned earlier, I have a module called simple parameters, and that parameter is a dummy. I mean, that module is dummy. I am not giving any input or output port, but I am going and defining a parameter of width 8. Okay, and I am trying to print that what is that width. That's it. It is a simple code for the parameter. It is a simple code for the parameter. Okay, that width we got it as an 8. Okay, now you see this I can instantiate through this also. Even I can write we will get the same thing. Okay, so here the simple parameter, and we are instantiating it through an instance, and then we were trying to do it. Okay, so now we will check for the multiple parameters and its test bench. Okay, the multiple parameters, and we will try to have. Okay, so with 8 depth, so how? The same thing. Verilog 2 underscore multiple and 2 underscore test bench. Okay, and then VVP, you will be able to get the thing. So how to use the parameters, we come to know this. Now we will talk about the override. These are the things which the concepts which you guys want to understand it little bit clear. Okay, so here already I passed the 8 and 16 it over here. In the instance, I am trying to override it. I am trying to override from 8 to 16 and 16 to 32. Okay, so I mean this is 32 and 64. I'm trying to change 32 and 64, and I should get, because here instantiation, and I'm trying to override the parameter what I have going to given it over here. What I'm trying to tell is using this parameter at the runtime by using an at the time of creating the instances, you can go on to change it. Okay, so that is what my claim is. Okay, so let me go and use override and 3 underscore test bench override. Okay, so let me go and clear it. Let me go and clear it, and then VVP a dot out. Okay, so now it changed. See, even though we are trying to print, this is the thing, at the initial time we have went and used 8 and 16, but at the time of instantiation we went and overridden our things. Okay, so this is the important thing which you have to understand. Now the name overridden, parameter by name overriding. Okay, what? Okay, see, as like creating an instance, we try to map. No, okay, so here you can go and use this name. Previously directly with the position we went and overridden, but here by the help of name we are trying to override it. Okay, overriding the stuffs. So these are the things which you can name. And then what is the thing? 4 underscore, and I have test bench. Okay, so VVP a dot out. Okay, so it has been overrid with the name, something like the position and the name, you can think like that. Okay, now bus parameters. Okay, you see that here I am declaring the parameter, and I have input and output. This is the bus, input port, output the port, and I am assigning A and B, and I am trying to assign the A and B. Then here the width is going to be 8 bit, each is of having an 8 bit. Okay, so that is the idea. And now I am trying to write a evaluate this design. I am trying to evaluate this design. Okay, so this A, B, and C, I want to map a signal in our test bench. I am using with the same kind of things, and Y is an output. Okay, and here you see that I am mapping the width. I am mapping that width. That also, when I try to create an instantiation of this hardware in the parameter bus, I am creating a new instance of device under test, and there I am trying to write the uh, parameter, and then I am mapping the signals. I am trying to map this signal with the our input and output port, and trying to look it in the things. Okay, it is simple only, but if you able to understand it, it will be good. Okay, but easily we will get confused. That is the problem with the vectors, arrays. Okay, parameters, somehow you will be able to do it. Okay, the mapping, the name, and everything, so it need a little bit practice. So I am requesting you guys to try to do a practice, even though it looks simple, whatever the program which I am giving, even though if it looks simple, but please go and try yourself by one. Okay, so this is about the, okay, so the width parameter here I am able to change it. And for the test bench, okay, here the width is 4. Okay, the same I am using it. If you want to override, you can go and override it, and you can go and do it. Okay, so now let me go for an local parameter. This is the thing which you need. Okay, local parameter, we will try to look into it. Okay, yes, within this one file there is no problem. I'm creating an idle as local parameter, and then run on local parameter stop and assigning the state. And then I am trying to print by using idle run and things. If I try to access this idle with some other file, I cannot able to get it. Okay, that is one thing that you can see through this example. One of this example, you can go and look into it. Okay, this example you can see to it. Okay, so now I have a local parameter, it is double width. Local parameter is double width, and using the width I am trying to use it. Okay, you see this width, you can override it. By overriding this, I can change it. Okay, that is the idea. In the test bench, what I'm trying to do is I am trying to override it with 16. I'm trying to override it with 16. Okay, I Verilog. Okay, and if I put 8 underscore local 8 underscore test bench, and then let me go and clear it, and then vvp a dot out. Okay, it went and override. See, local parameter you cannot change, but by using this we are able to do something. Okay, now, okay, this is the local param. Okay, so this local param is for this only. Okay, when you try to change this double width, then the problem comes. Okay, that you shouldn't do. Okay, so let me see, there is one called local. Okay, so there is, okay, in the test bench width only I am able to change, but I cannot go and change this internal width. Okay, if I try to change this internal width, then we will not be able to get the things. Okay, we will not be able to get the things. So maybe I will try to go and change the it is the module is test, the test module. Okay, so there inside this local param, okay, internal width. Okay, this is the internal width. Let me try to change it. Okay, so for the device under test, okay, let me go and One second. Okay. I didn't save the file, so it went and compiled. It is giving me a 16. Okay, let me save the files. Okay, okay. So there is one syntax error. Let me go and use it here. Okay, so we cannot change, we cannot go and change. That is what it has been written it over here. Okay, it is the parameter, the test, and it is not written with this, it is using with local param and internal. We cannot go and change that. That is what I was trying to give you an idea. Sir, I have Mac OS. Is there any separate APK or file to do this, sir? Okay. So since you are using the Mac OS, okay, one second. Yes, there is a support. Okay, let me put it in the chat. Let me put it in the chat. There is a support. Okay, you can check. You can go and use brew, install iCares Verilog, where you can go and use it in the Mac OS. Okay, and you can check. Okay, you can check open source tool and something like that iVerilog, Verilater, VVP. How do I install in Mac? You will get an it automatically, the AI will guide you. Okay, if there is a iCares Verilog for the Mac OS, you can go and use it. Okay, that's not a big deal. Okay, so this is about the parameter. When it comes to the I will come to memory later. Maybe I will go for the strings. Okay, maybe I will go for strings. It is somewhat easy to understand for you all. Okay, so this already we looked in our theory class, and strings. Okay, similar, the command prompt, and there will be only a small changes in the commands when we try to use the Mac OS. Okay, so let me go and print the strings, and then VVP a dot out, VVP a dot out. I am able to print the hello. If I want to print the full string, you see that hello. Okay, so here I am mentioning 8 because I want to print the string, so I want to have something. Okay, let me try to put, okay, it is something, it goes from 40 minus 1, that means 39 to 0, 40 things. Let me go and use some k. Okay, and let me check what it is happening. I think it will go and truncate it. It will not print the k. But when I try to put the k over here, it will not print 0. You see that ELLO, this O, it is not printing. So it is taking only this much of the size. Whatever the size we gave, only that we are able to get it. That you have to understand. Okay. This is the print string. Okay, so here I went into 88 and I have given more thing, and it will be able to print iVerilog in the to VVP a dot out. Okay, Verilog lab. Okay, now the concatenation. If I want to concatenate yellow and world, already I told we have a concatenation operators. So where you can go and use it. Okay, I Verilog and then 3 concatenation and then VVP A dot out. Okay, so I'm able to concatenate. Okay, so likewise you can go and use it for the characters. Okay, extract the first character. If I want to extract only the first character, I can go for the slicing operator. So these are the from the slicing operators we are trying to extract only the first character of my the stuffs. Okay, something like uh, the thing first 8-bit. So it is hello. Okay, the next is something for the storage. Okay, so here okay, here the each is having this much and I have three element